How does path planning work in robot programming? Imagine a robot trying to navigate through a crowded room filled with obstacles. How does it know where to go without bumping into anything? This is where path planning comes into play. Path planning is all about figuring out a safe route for a robot to travel from one point to another while avoiding obstacles. The first step in this process is creating a map of the environment. This map can be simple, like a grid where each cell is marked as either free or occupied, or more complex, using shapes to representing spaces. The grid maps are popular because they work well with algorithms that help find the best paths. Next, the robot must consider its own size and shape. This is done using something called configuration space. In this concept, the robot is treated as a point, while obstacles are expanded to account for the robot's dimensions. This ensures that the planned paths keep a safe distance from any obstacles. There are two main types of algorithms used for path planning: search-based and sampling-based methods. Search-based algorithms, like a Star and Dijkstra's algorithm, systematically explore the map to find the best path. They evaluate possible moves to minimize costs like distance or time. On the other hand, sampling-based algorithms, such as rapidly exploring random trees and probabilistic road maps, randomly select points in the configuration space. These methods are particularly useful in complicated environments where searching every possible path would take too long. Once a path is identified, it can be refined to ensure it is smooth and feasible for the robot to follow. Controllers then convert this planned path into commands that the robot's motors can understand. In modern robot programming, path planning is often combined with perception systems that help the robot sense its surroundings and control systems that execute its movements. This combination is essential for autonomous navigation. Additionally, machine learning techniques, like reinforcement learning, are increasingly being used to help robots adapt to changing environments. Path planning has many real-world applications. For example, autonomous vehicles use it to navigate roads safely, drones use it to fly through obstacles, and robotic arms use it to move around objects without collisions. Software tools like MATLAB and Simulink are available to help developers create, simulate, and implement path planning algorithms, supporting various methods for real-time trajectory generation. In essence, path planning in robot programming involves mapping the environment, understanding the robot's configuration, applying algorithms to find safe paths, and generating commands that allow the robot to move efficiently and autonomously.